Hello students, welcome back to the another video of AI and machine learning. So today we are here with another video. So in the earlier videos we have learned about the logistic regression and the linear regression. So in the today's video our topic is to learn the neural network. So I will tell you what the neural network is. So it's like a computer system that can learn from the data like the way our brain learns. To do this, today we are using the Lorenz system. It's type of like a differential equation, which will create some data, and on the basis of that data we are going to train our neural network to behave and predict the coordinates like x, y, z. So to understand that what the Lorenz system is, and actually I will show you the equation, that how the equation look for the Lorenz system. So look, these are like three like deterministic differential equation that describe the chaotic system. When it comes to the machine learning and AI part, it's not inherently tied with this. It's like a mathematical model that generates the transaction on the axis. So if I will go on the deep, these are the equation, and the equation have been given by the Lorenz in certain 90s, and like what make this equation like unique, how this equation will behave chaotically. So he told to the system like if we will put the value of sigma is equal to 10, rho is equal to 28, and beta is equal to 8 by 3, and the initial condition from like at the start, like x is equal to 0, y is equal to 0, whatever the thing is, then after certain steps, like if you go to one step on the second sample or third sample, there will be a difference, but it will be very small difference, but the same thing we will repeat like over like thousands of samples or thousands of steps. In that case, we can see that the small input will change the result. The result will be drastically, and it will be unpredictable, and it start behaving chaotically. So that result, if we are going to plot on the coordinates on x, y, and z axis, in that case we will see a butterfly effect. That butterfly effect is known as like Lorenz system or Lorenz equation. It has a various of application in embedded system and in electronics. Like now they have been proposal to create an end-to-end encryption using this Lorenz system. So, or like the chaotic system. So it is a very explore, and like it's very good topic to learn. So we will, like in this video I will try to train a neural network. In this neural network I will tell to the model like this is a particular equation with some certain condition. The condition are like sigma is equal to 10, rho is equal to 28, and beta is equal to 8 by 3, and then we will ask to the Python to calculate and understand. And in the later we will train a neural network using the model called LSTM. It's a part of a neural network. It's approached how to train a neural network, and then we will see the prediction. And like it's like a challenge to the neural network, like because we know that like a Lorenz system behave chaotically. So it means chaotically means like the results are not predictable. It can change over time. It will change drastically, and it's very hard to predict. And we will ask to the neural network to learn from the pattern, to learn from the generated data from the Lorenz system, the synthetic data, and then we will ask to predict. We will see that how the neural network is learning, and we will see the result after the video. So now in this video I'm going to train an AI model or train a machine learning model based on the technique called neural network, where why it's called like neural network, because it will learn like a human brain. The neurons are connected to each other. There are like certain techniques also called like feed forward, back propagation, and so on. And like yeah, these are the things which we can explore. But in this specific video I will train a simple neural network, and we will see that how the thing's gonna work. So like if we say like in the starting we will import the libraries, then we will set the seeds for the reproducibility, because the random seeds, like because the randomness is like involved in the neural network. So setting the fixed seed to get the same result, and then the Lorenz system is small changes in the input, and we will see the big changes in the output or in the results. So this could be like tricky because it changes the unpredictable way. To do this we are using this three equation, the Lorenz system, and let's see that how the thing's gonna work. So now I will start the training of this machine learning or AI model based on the neural network, and I will show you that how the thing's gonna work. And in the later video, first I will do the coding, and later I will try to explain each and everything, that how the this code is working and how we are training that things, and like we will see that how the thing's gonna work. So let's start. So first, like I will try to write the code, and after the code I will try to explain the things, that how the thing's gonna work. So I will try to write the code as soon as possible, and I will also try to increase the speed to make the things done quickly. So let's start. So in the previous video we work on the test2 directory. So here we will do nano test.py, and I will write the code, and after writing the code I will try to explain each and everything, that how things work. And if you have any specific question you can ask on the comment section also. So I will Yeah. So okay guys, here we are done with the coding part, and now I will show you that how I have developed this neural network and how it is going to predict the Lorenz equation, how the things are working. So before we go and move, I will try to show you like this. These are the important libraries which have been used to develop this neural network, as well as how it will help you to solve the differential equation of the Lorenz system. So like the TensorFlow is used for this neural network as for the machine learning. Matplot is for the plotting of the data, this graph. Skip integrate is used for the solving of the differential equation, and this is used for because I have plot a 3D graph where I will show you that how the Lorentz butterfly effect will be shown. Now moving on the main part, I will show you that this Lorentz system definition. So this function defines that how the Lorentz system works. It is like defining how the value will change, because Lorentz has given the three specific value of sigma, rho, and beta, which are unchangeable. So we are working with that, and in the beginning of the video I shown you that the equation. So this is the same equation. It has been written in the Python form. Now moving on the main thing, we have generated the data. So we want to simulate from time from 0 to 40 seconds. The starting point in the 3D space will be x is equal to 1, y is equal to 1, and z is equal to 1. To solve it's generate the value every step, and it takes the transpose of each step, like this solve. Okay. And moving on the next part, the prepare is prepare of the data. So here our model is we look at the 20 time of a step. It means we prepare the data set as pairs of 20 inputs and one output. Now moving on the building of the model. So here in the model, the first layer is LSTM. It processes the each step. The output is consist of 3 layers. It gives the value of x, y, and z. It will go through the 30 times with the certain batches. That batch size has been given is equal to 64 and so on. And then we have done all the plotting parts, and because during the scripting of the code there were some issues, so I have just corrected, and this is the better form of the code. So right now we are gonna compile this, and we will check whether the things are working or not. So I will show you that how it's gonna work. So, and now we will do the Python test.py, and we will type the enter, and we will see that how the things are working. It will compile because I have done testing before showing you guys. So look, it is going for it consists of total of 30 epochs. 30 epochs means the machine learning and this neural network is learning 30 at time, as well as you can see this each batch size consists of 64 times of the data, and this is how the things are working. Now if we see on the training and the number of epochs, this graph, so I will show you that how the graph is working. So you can see that here the number of epochs is 30, and the graph is getting depreciated. It means that the over the number of time the epochs are getting increased, it means that the prediction of the model, the neural network, is getting improved. Now I will show you the plottings, the loading. So you can see that this is called the real butterfly effect. This is like also known as the Lorenz butterfly effect. And the red one, the true one, is like which is already been defined by the Lorenz, and this one, the red one, is like being predicted by our neural network. So you can see that like it's quite good, but it's not that good, because the reason is like the Lorenz system is unpredictable and it is chaotic in nature. So you can see it's try to get into that prediction. It means like I'm trying to say like it's try to predict the Lorenz system, the chaotic behavior, and it's done quite pretty so far. But it's not that much good, because it's like because initially if we have like 10 or 100 of steps, the values will be slightly different. But if we go to like 100 of samples or 100 or 1000 of samples, in that case it will become heavily chaotic and it will be very hard to like predict. Still our neural network have done very good work. It's predicted so far pretty so far good. And now I will show you that during the initial, that how the things are working initially, like for some certain steps, like how the prediction was done, how it was better or bad. So let's see. You can see like for 100 of steps our model tried to predict as pretty far as so good. But yeah, so from this graph, what I can say, like we saw that how the neural network that predict the chaotic behavior, but we can say that it has been lost over time. So in the conclusion, I will say that the neural network is powerful, still it struggle to predict the Lorenz system because of the chaos or the chaotic nature. So that's why the Lorenz system is quite powerful, or not powerful, but heavily chaotic. So it makes the neural network still to struggle to predict as pretty far as so good. So yeah, this is all about the video. So in the video today we have learned about that how you can train a neural network, and we have challenged that like how the neural network can or yes predict or not this our model. So yeah, so this is all about the video. I hope you like this video, and I also want to say that like I will try to upload this code on the GitHub, because I just tested this code. It is like this is the refined version, or like the better version of my previous codes. So I will try to upload as soon as possible, and like once I will have uploaded on my GitHub, I will post on YouTube that I have uploaded, and you can go and you can visit if you like. So yeah, this is all about this, and like in the next video we will do something more interesting, and I will also start the series of embedded system. I have developed intrusion detection system and end-to-end encryption system, so I will try to show you that on the video. So yeah, we have a lot of good things to come. So stay tuned. If you like this video, please share,